Okay, good. I think we're live. And long day. Last stream, I don't know. Last stream till I actually do something. I released the reel today. And we can watch it together. Sorry, I'm a little bit lethargic today, I think. And today we're going to do it a little bit different. We're not going to do the classic high-level review. Instead, we're going to look. So today is day 10 of self-learning rocket science, and today we're going to do it a little bit different. We're not going to do the classic high-level review. Instead, we're going to look back first. So 10 days, back-to-back, day in, day out, self-learning rocket science, boot camp style. Remember, the purpose of this I mentioned in previous videos was, yes, we're going to learn a cool skill, but more importantly, we're going to figure out how best to learn and build our skills meaningfully with the tools that we have, namely LLMs. So these last days have been huge sessions with GPTs, picking at its artificial brain. I'm pretty sure they're handing out like plaques for token usage, and I'm climbing up the leaderboards. But here's the thing, these last 10 days, I reached some really important aha moments, some right on stream. I just thought of an insanely good idea. Oh my god, dude. I need a build product. I can't do this anymore. I'm going to go build. It feels like a real sense of clarity, and the next logical step here is to put those ideas onto paper. And I think it would be a huge disservice not to prioritize the building stage right now, and I really want to just stay on top of it. So next time I make one of these videos, I actually want my ideas on hand. And anyways, I'll still do a day 10 live stream, and then I have to go dial in. But yeah, today's day 10. So today is day 10 of self-learning rocket science. So, as you heard, today is the last live stream until I can actually get a working demo out. Not demo, working iteration out. So, yeah, I was thinking about it. I was just like, okay, so I basically, like, I have this plan and everything. I mentioned that I would like to build first, and as if you couldn't tell already, like, a lot of the problems that I've been having have stemmed from doing what I'm about to do for the next hour and something, which is, hold on, let me pull up the thing over here. Excuse me. I'm gonna wipe that up. Yeah, so it's in response to what I was doing basically here, which was solving this right here. I mean, that's probably, this is only for one problem, but a lot of the times my other stuff, it kind of looks like this. Very long-winded. A lot of questions here. I'm crying because I've been yawning so much. Lot of clarifications, definitions. Messy. So like I said, navigation of context window, number 1. Let's do myself a favor and Sick. So a lot of the problems I've been facing, response to this, I think it's important to, at each step of the way, mark what's up, basically. So, understood, don't understand. And maybe understood is going to be a less usable feature than didn't understand. Understood is going to be a less used feature than. I'm not too sure though, because basically what not understanding is just going to re-enter it into the chat. Like I didn't understand that. As simple as that. And you can obviously clarify as much as you would like, but that's going to be the simplified version. What that allows you to do is work with the nav like pretty easily. So it will sort is what I'm trying to say here. Now is also going to have like all the fancy features. So I'm talking summarize period. Like these are going to be some long-winded chat sessions, key. So you're going to want it all wrapped up, bundled up in the way that you understood it. That's when maybe that understanding button is going to come into play. Like that will make sense. Otherwise, yeah, so it's going to have that. It's going to have a lot of nice widgets. Like whenever you ask definitions, maybe that's going to get stored in all of the definitions, flashcards kind of situation. Easiness dragger, how nice is it talking to you? Or how detailed is it talking to you kind of situation. Document upload, of course. And yeah, like that's basically what's going on right here. So let's bet. It feels like rocket science trying to learn rocket science. As far as like navigating the GPT sometimes I need ease of use. I want to be able to navigate through it. So that is that. Sick. So let's get right at it. Let's finish this problem set. I got root beer. I haven't drank root beer in so long, so it's very nostalgic today. Last day celebration root beer. Not really last day. Last stream until I built, so maybe like a beginning of the journey kind of situation. So let's just make sure that we understand. See, this is exactly what I'm talking about. Whenever I need that review, I need to, I would like to summarize. I need to have something to summarize. So and then we'll check on that. I did not expect. 2 days ago was my most liked content, so I was like pretty happy about that. But Yesterday I by accident used the song in Espresso. Sabrina Carpenter's Espresso. I used like a little bit of that for the ChatGPT screen, and I think the algorithm didn't like that because I posted on Instagram and TikTok, so it was like pretty. Both of them weren't performing as much as my videos usually perform. So I was that makes sense that it would be because of that. Copyrighted music. I should be careful for that. Anyways, today it feels nice to finally like have time to just focus in right now because that's very important. Anyways. So which part of the problem was this? Part D, right? No. I didn't even realize that. Was this it? Yeah. No, maybe we have to go back like this. These terms go away and then what was that direction again? O is that one term. Which one term? This one term. Technical definition. Okay, good. Understood. And where's our problem? Here it is. Let me grab my notebook. No, we'll just do it note style on there on this other screen. Nice and easy. Mm-hmm. Mm-hmm. Nabla V. So automatically So what did it say? Picture a 2D flow. I understand that V is O. I think I skimmed past that earlier. Let's see what it has to explain. Got it. What is this again? Dot product? Oh. Makes sense. No. I'm okay. Stretch tilt what? The stretch tilt term is dependent on z, it says. Material derivative. Oh my! I swear this is a product of lethargy. Z. Ooh. Okay, wait. So that means that we're done with that. Okay, like just because today is gonna be rough, we're not going to step into this 40% big absolute beast of a problem. I don't want to perpendicular to hanger. Man, I'm just like blown away. Like how this is 2005. It says right here, right? I'm pretty sure. No, it doesn't. Anyways, it is from 2005, and I'm like, what in the world? These kids had to be cracked or some G-wrote memorizers. I remember a funny little story. I have a very good friend of mine. He's doing so good for himself, and he's like very inspirational, very like book smart. He knows, like, he's always been very accomplished as far as like getting the best of the best jobs and doing the best in school and getting into the best schools and stuff. And he studied at MIT, and his undergrad, I remember he entered physics. By the way, he was like the sharpest kid in high school, and the sharpest kid. He got into all of his dream schools, so he ended up choosing MIT. And like, I mean, I think I relate in the same sense, but like, it went from big fish in little pond to little fish in big pond. Kind of, that's like what college does for you, especially when you go to like an institution like that. So he went to MIT, and he took a physics class, and in the physics class, the smartest kid I know, I'm not even joking. His professor recommended that he basically was just like, you shouldn't be taking this class, like it's too above your head, like you need to do better, you don't have enough understanding of the class. And he basically like gave him the boot, and like this kid is like G'd up. I think he became like a quant at like a really prestigious not a prestigious, but like a really nice prop shop. And then whatever, he's working in OpenAI and stuff now. But I thought it's funny, like that makes sense. now I'm still, I bet if that's what he said to this guy, I don't know how ruthless my message would have been. It probably would have been the same, just a little bit more intent behind it. So yeah, let's go. We finished. I'm glad that we got a problem done though. This was an easy stuff. I think it's at a good rate too. Like, now that we're nailing one at a time. Like, this is 1-2 problems I could probably answer given that. And of course that. If I do a problem a day, I would have submitted it on time. I also do think that I ran into that problem in school when I was in school. The fact that I didn't time it off. I didn't split it up effectively enough. I wasn't strategic about when should I get some of this done across all classes. It could have just been, let me get some of this done now, some of this done later, tomorrow. Spaced it out, not stress about it, not feel a pride problem, being like, I can just get it all done now, and then just end up burning out. But yeah. Anyways, nice thing I get to ask the GPTs all I want. So let's do a quick little 3 blue, 1 brown.
Imagine bringing your side project to life.
No. I love that. Wow. Yes, yeah.
Hey everyone. If I had to choose just one topic that makes all of the others in linear algebra start to click, and which too often goes unlearned the first time a student takes linear algebra, it would be this one: the idea of a linear transformation and its relation to matrices. For this video, I'm just going to focus on what these transformations look like in the case of 2 dimensions, and how they relate to the idea of matrix vector multiplication. In particular, I want to show you a way to think about matrix vector multiplication that doesn't relate to matrices. For this video, I'm just going to focus on what these transformations look like in the case of 2 dimensions, and how they relate to the idea of matrix vector multiplication. In particular, I want to show you a way to think about matrix vector multiplication that doesn't rely on memorization. To start, let's just parse this term, linear transformation. Transformation is essentially a fancy word for function. It's something that takes in inputs and spits out an output for each one. Word for function. It's something that takes in inputs and spits out an output for each one. Specifically, in the context of linear algebra, we like to think about transformations that take in some vector and spit out another vector. So why use the word transformation instead of function if they mean the same thing? Well, it's to be suggestive of a certain way to visualize this input-output relation. You see, a great way to understand functions of vectors is to use movement. If a transformation takes some input vector to some output vector, we imagine that input vector moving over to the output vector. Then to understand the transformation as a whole, we might imagine watching every possible input vector move over to its corresponding output vector. It gets really crowded to think about all of the vectors all at once, each one as an arrow. So, as I mentioned last video, a nice trick is to conceptualize each vector not as an arrow, but as a single point, the point where its tip sits. That way, to think about a transformation taking every possible input vector to some output vector, we watch every point in space moving to some other point. In the case of transformations in 2 dimensions, to get a better feel for the whole shape of the transformation, I like to do this with all of the points on an infinite grid. I also sometimes like to keep a copy of the grid in the background, just to help keep track of where everything ends up relative to where it starts. The effect for various transformations moving around all of the points in space is, you've got to admit, beautiful. It gives the feeling of squishing and morphing space itself. As you can imagine, though, arbitrary transformations can look pretty complicated. But luckily, linear algebra limits itself to a special type of transformation.
That was super cool.
Ones that are easy for various transformations moving where it starts. A copy of the grid in the background, just to help keep track of where everything ends up relative to where it starts. The effect for various transformations moving around all of the points in space is, you've got to admit, beautiful. It gives the feeling of squishing and morphing space itself. As you can imagine, though, arbitrary transformations can look pretty complicated. But luckily, linear algebra limits itself to a special type of transformation, ones that are easier to understand, called linear transformations. Visually speaking, a transformation is linear if it has 2 properties. All lines must remain lines without getting curved, and the origin must remain fixed in place.
Once again?
Transformation is linear if it has 2 properties. All lines must remain lines without getting curved, and the origin must remain fixed in place. For example, this right here would not be a linear transformation, since the lines get all curvy. And this one right here, although it keeps the line straight, is not a linear transformation, because it moves the origin. This one here fixes the origin, and it might look like it keeps lines straight, but that's just because I'm only showing the horizontal and vertical grid lines. When you see what it does to a diagonal line, it becomes clear that it's not at all linear, since it turns that line all curvy. In general, you should think of linear transformations as keeping grid lines parallel and evenly spaced. Some linear transformations are simple to think about, like rotations about the origin. Others are a little trickier to describe with words. So how do you think you could describe these transformations numerically? If you were, say, programming some animations to make a video teaching the topic, what formula do you give the computer so that if you give it the coordinates of a vector, it can give you the coordinates of where that vector lands? It turns out that you only need to record where the two basis vectors, I hat and j hat, each land, and everything else will follow from that. For example, consider the vector v with coordinates -1, 2, meaning that it equals -1 times I hat plus 2 times j hat. If we play some transformation and follow where all three of these vectors go, the property that grid lines remain parallel and evenly spaced has a really important consequence. The place where v lands will be -1 times the vector where I hat landed plus 2 times the vector where j hat landed. In other words, it started off ended consequence. If we play some transformation and follow where all three of these vectors go, the property that grid lines remain parallel and evenly spaced has a really important consequence. The place where v lands will be -1 times the vector where I hat landed plus 2 times the vector where j hat landed. In other words, it started off as a certain linear combination of I hat and j hat, and it ends up as that same linear combination of where those two vectors landed. This means you can deduce where v must go based only on where I hat and j hat each land. This is why I like keeping a copy of the original grid in the background. For the transformation shown here, we can read off that I hat lands on the coordinates 1, -2, and j hat lands on the x-axis over at the coordinates 3, 0. This means that the vector represented by -1 I hat plus 2 times j hat ends up at -1 times the vector 1, -2 plus 2 times the vector 3, 0. Adding that all together, you can deduce that it has to land on the vector 5, 2. This is a good point to pause and ponder, because it's pretty important. Now, given that I'm actually showing you the full transformation, you could have just looked to see that v has the coordinates 5, 2. But the cool part here is that this gives us a technique to deduce where any vectors land so long as we have a record of where I hat and j hat each land, without needing to watch the transformation itself. Write the vector with more general coordinates, x and y, and it will land on x times the vector where I hat lands, 1, -2, plus y times the vector where j hat lands, 3, 0. Carrying out that sum, you see that it lands at 1x plus 3y, -2 record of where gives us a technique. Now, this is the vector 2. This same linear combination of where those two vectors landed. This means you can deduce where v must go based only on where I hat and j hat each land. This is why I like keeping a copy of the original grid in the background. For the transformation shown here, we can read off that I hat lands on the coordinates 1, -2, and j hat lands on the x-axis over at the coordinates 3, 0. This means that the vector represented by -1 I hat plus 2 times j hat ends up at -1 times the vector 1, -2 plus 2 times the vector 3, 0. Adding that all together, you can deduce that it has to land on the vector 5, 2. Plus it's the coordinates 1, -2, and j hat lands on the x-axis over at the coordinates 3, 0. This means that the vector represented by -1 I hat plus 2 times j hat ends up at -1 times the vector 1, -2 plus 2 times the vector 3, 0. Adding that all together, you can deduce that it has to land on the vector 5, 2. This is a good point to pause and ponder, because it's pretty important. Now, given that I'm actually showing you the full transformation, you could have just looked to see that v has the coordinates 5, 2. But the cool part here is that this gives us a technique to deduce where any vectors land so long as we have a record of where I hat and j hat each land without needing to watch the transformation itself. Write the vector with more general coordinates, x and y, and it will land on x times the vector where I hat lands, 1, negative 2, plus y times the vector where j hat lands, 3, 0. Carrying out that sum, you see that it lands at 1x plus 3y, negative 2x plus 0y. I give you any vector, and you can tell me where that vector lands using this formula.
Let me think about this. I remember this. I used to really memorize this. I like the intuition here, though. Makes sense. Okay, fine.
What all of this is saying is that a two-dimensional linear transformation is completely described by just 4 numbers, the 2 coordinates for where I hat lands and the 2 coordinates for where j hat lands. Isn't that cool? It's common to package these coordinates into a 2x2 grid of numbers called a 2x2 matrix, where you can interpret the columns as the 2 special vectors where I hat and j hat each land. If you're given a 2x2 matrix describing a linear transformation and some specific vector, and you want to know where that linear transformation takes that vector, you can take the coordinates of the vector, multiply them by the corresponding columns of the matrix, then add together what you get. This corresponds with the idea of adding the scaled versions of our new basis vectors. Let's see what this looks like in the most general case, where your matrix has entries A, B, C, D. And remember, this matrix is just a way of packaging the information needed to describe a linear transformation. Always remember to interpret that first column, AC, as the place where the first basis vector lands, and that second column, BD, as the place where the second basis vector lands.
BD.
When we apply this transformation to some vector xy, what do you get? Well, it'll be x times AC plus y times BD. Putting this together, you get a vector ax plus by, cx plus dy. You could even define this as matrix vector multiplication when you put the matrix on the left of the vector like it's a function. Then, you could make high schoolers memorize this without showing them the crucial part that makes it feel intuitive.
That's me, bro.
But isn't it more fun to think about these columns as the transformed versions of your basis vectors, and to think about the result as the appropriate linear combination of those vectors? Let's practice describing a few linear transformations with matrices. For example, if we rotate all of space 90 degrees counterclockwise, then I hat lands on the coordinates 0, 1. And j hat lands on the coordinates negative 1, 0. So the matrix we end up with has columns 0, 1, negative 1, 0.
Cool.
To figure out what happens to any vector after a 90-degree rotation, you could just multiply its coordinates by this matrix. Here's a fun transformation with a special name, called a shear. In it, I hat remains fixed. To figure out what happens to any vector after a 90-degree negative 0, 1, 90 degrees counterclockwise, then I hat lands on the coordinates 0, 1. And j hat lands on the coordinates negative 1, 0.
J hat.
So the matrix we end up with has columns 0, 1, negative 1, 0. To figure out what happens to any vector after a 90-degree rotation, you could just multiply its coordinates by this matrix. Here's a fun transformation with a special name, called a shear. In it, I hat remains fixed, so the first column of the matrix is 1, 0. But j hat moves over to the coordinates 1, 1, which become the second column of the matrix. And at the risk of being redundant here, figuring out how a shear transforms a given vector comes down to multiplying this matrix by that vector.
Got it.
Let's say we want to go the other way around, starting with a matrix, say with columns 1, 2, and 3, 1, and we want to deduce what its transformation looks like. Pause and take a moment to see if you can imagine it.
You have to multiply this by the transformed.
One way to do this is to first move I hat to 1, 2, then move j hat to 3, 1, always moving the rest of space in such a way that keeps grid lines parallel and evenly spaced. If the vectors that I hat and j hat land on are linearly dependent, which, if you recall from last video, means that one is a scaled version of the other, it means that the linear transformation squishes all of 2D space onto the line where those two vectors sit. Also note what's that end line. One way to do this is 1, 2. Let's say we want to go the other way around, starting with a matrix, say with columns 1, 2, and 3, 1, and we want to deduce what its transformation looks like.
Is that not what we just did before, though?
Forms a given vector comes down to multiplying this matrix by that vector, 2 and 3, 1, and we want to deduce what its transformation looks like. Pause and take a moment to see if you can imagine it. One way to do this is to first move I hat to 1, 2, then move j hat to 3, 1, always moving the rest of space in such a way that keeps grid lines parallel and evenly spaced. If the vectors that I hat and j hat land on are linearly dependent, which, if you recall from last video, means that one is a scaled version of the other, it means that the linear transformation squishes all of 2D space onto the line where those two vectors sit, also known as the one-dimensional span of those two linearly dependent vectors. To sum up, linear transformations are a way to move around space such that grid lines remain parallel and evenly spaced, and such that the origin remains fixed. Delightfully, these transformations can be described using only a handful of numbers, the coordinates of where each basis vector lands. Matrices give us a language to describe these transformations, where the columns represent those coordinates, and matrix vector multiplication is just a way to compute what that transformation does to a given vector. The important takeaway here is that every time you see a matrix, you can interpret it as a certain transformation of space. Once you really digest this idea, you're in a great position to understand linear algebra deeply. Almost all of the topics coming up, from matrix multiplication to determinants, change of basis, eigenvalues, all of these will become easier to understand once you start thinking about matrices as transformations of space. Most immediately, in the next video, I'll be talking about multiplying two matrices together. See you then.
Great. I don't care about the comments. That's my force of habit. I'm just trying to be like, I don't do that. Wow. That's funny. What are we at here? 50 minutes? Okay, we can mess around with something. I think I've highlighted my issues pretty largely with what I have here, so I don't wanna keep bashing my head in. I mean, I could, like, I should, maybe, for the purpose of getting to my time limit here, but yeah, I mean, we could pull up textbook, I guess. Load up. Is this a Wi-Fi problem?
This is hands down one of the most powerful AI platforms for digital marketing, SimilarWeb. And honestly, if you run a business nowadays without this, you're most likely going to lose to your competitors. Because this platform allows you to literally dig into all of your competitors.
Little heartbreak sign. to commemorate the end of the 10 days.
I heard that you settled down.
I didn't do anything.
That you found a girl and you're married now. I heard that your dreams came true. Guess she gave you things I didn't give to you. Oh, friend, why are you so shy? Ain't like you to hold back or hide from the light. I hate to turn up out of the blue uninvited, but I couldn't stay away. I couldn't fight it. I had hoped you'd see my face and that you'd be reminded that for me it isn't over. Never mind, I'll find someone like you. I wish nothing but the best for you too. Don't forget me, I beg.
Alright, enough of the Adele. You know, I know, okay, like, for people who do post reels, like, I'm not the influencer type. Like, let's be honest. Like, it was a very, like, how do I say this? It was a journey. First of all, getting out of my comfort zone, okay? I'm not, like I said, I don't post content like that. And then all of a sudden I post 9 days of content, okay? Not even 9 days, more than 9 days. Here, let me go to OBS. Okay, we're talking boom, boom, binga, banga, boonga, banga. All the way up to, I mean, there's some more here on the top, right? So here I am, like, just all the people, like, that I used to just be very low key. I liked my public perception to be close to the chest. And once you do stuff like that, it goes out of the door. So, like one of my biggest inhibitions was like, oh my God, like everybody gets to see this. At some point you just like, it just leaves, depletes, like you couldn't care less because you just have to do what you have to do. Like it just does not matter. And so this is one of those, like I've been posting 10 days. I've honestly like, a lot of people were reaching out like, oh, like interesting, dude. Like what's like people that I used to have like a different probably perception in their head. Like it wasn't. I mean, like this is some pretty like complex stuff, very challenging stuff, very niche. Like day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of learning rocket science. Like who's interested in that, other than like a very niche group of people? So all the people that, you know, maybe I was in. I used to hang out to like just have fun, or just like they were around and we were just like, you know, I don't know, people that didn't see that side of me are just like, oh, didn't even realize you were about that life. So I'm like, yeah, I very much am about this life. I like rockets, which sounds crazy. Like I'm like, I really do. I'm passionate about it. And like I said, the point and purpose of this all was to get very, very in touch with this, basically. Like, understand what this needed. And I've gotten some clarity about it. So, thank God I just, like, or whatever, thank the universe that I did it because I wouldn't have like a very like clear next step in my head. And I do now, so grateful for that always. Enough yapping. Back to rocket parts. And I'm not even gonna pretend I'm not done yapping, okay? I mean, it's literally only me watching this live stream. I'm just talking for proof of process here, but like I'm not gonna pretend. I use this as an opportunity to, get really in touch with all of these knowledge dumps, and I've done my fair share of system prompting here and workarounds, and now I've officially convinced myself, and I have some pretty delusional self-belief that I know what it takes to really solve this up. I'm talking about making this easier for a user. Searching and organizing, making context window more friendly. Maybe a nice part of the larger vision is it gets to be a nice front end for there's something called, I think it's called, let me just search it up on here just to make sure. Typing mind, it says. Not curious about their fucking around. There's this interesting web UI called Typing Mind. This is so cool. It's like a front end, right? For GPT, just a lot more easier, agent-based, kind of allowing for many GPTs. So that's what mine could be doing. Like I know the niche I'm going to be tackling is very for ChatGPT. So not just ChatGPT. Some LLM. So bang. Back to rocket parts. Anyway, we will throw on some. What's that one song? No, we're not gonna do B2B Dead. I just heard that song on Kai's stream. Let's think. What's a good turn up song? We can throw in some classical, honestly. Let's do some arabesque. Debussy.
Most people don't do anything to achieve their goals. High achievers will tell you to build a roadmap, but in reality,
there's a beautiful song. Let me put you all on if you don't know. My friend Ramana Balachandran showed me this. Jeez. That's my family, by the way. I came up with it. That's hilarious. That's my family. Baba Skadoosh. That's my sister. Y'all can get it. It's like Baba Ganoush. They all have like Mediterranean food names. I don't know. It was just a thing. So my dad's Papa Pete, my sister's Baba. It was originally Baba Ganoush, and then I was like, I'm so quirky, and I put Skadoosh, like, you know, the whooshy finger holding Kung Fu Panda, Baba Skadoosh. It's stupid. I love it though. I'm just like, I'm forgetting that this is live stream, and I'm the only one watching. I hope, like, I'm just like doing it in the case that somebody else, like maybe an investor watches this and they're just like, he associates with Baba Ganoushas or Baba Skadooshas. I'm not gonna invest in it. That's my sister. Possible future person that watches this. I think, yeah, as soon as we finish this, I'm gonna say something. I realize that, I mean, it makes sense that it's all late, but. Got it. We read about that in the textbook. Indeed. Yeah. Forget all the payload and the whatever. What if this is propulsion, structure, and guidance? Nice and easy. Okay, good. What I was saying earlier was, I don't know if, I mean, when I said earlier that my reel got messed up, and like I used the Espresso by Sabrina Carpenter as my song, and I think it got like, that's a no-no unless you explicitly use it through Instagram's reel thing. And so when I posted it on TikTok, for example, boom, 0, like no views. Like I was 7 views, matter of fact, over like a day, and I had to just re-upload it, and I had to figure out some new music, and I was like, darn, that copyright's a real thing. It's like, what do I post instead? So I literally just like when I realized it, I was like, darn, I need to whip up something fast. And so then I threw on I went to Logic, and I was just like, so what I came up with, and this is what's over the video. I'll show you in a sec. Just that loop, right? And here, let's go to TikTok. We'll X this. So on Instagram, it's still Espresso. But over here, still my least learning rocket science. And yesterday we managed to get through a big problem, proving that pressure is constant in a streamline using Euler's flow equations. It was conceptually heavy on the linear algebra. The LLMs were working overtime with all of my questions. As far as pure linear algebra,
I just thought that was funny. We can go over here. That's true. This is true. I was just talking to my girlfriend about this. Like, I think the fact that you can, when you get huge, whenever anything gets huge, like a very, very normal and fair and secure way to go about things is to conserve. And we were talking, like, for example, like Apple's company, we don't see the pace of innovation that we did when, like, Jobs was maybe there, and now it's just like it's really like capitalizing, just, okay, let's just optimize what works. Makes sense. I'm not saying that that's bad, but stuff like this, you iterate fast and you treat like your huge big conglomerate as like it's moving as fast as a startup, basically. I'm like that's pretty, I respect that. That's how you actually get stuff done. And when you don't care about things like the ups and downs, or you're rather much wiser about them, knowing that they swing and you go up, or you're tending towards up, even if you just take the hit right now. But at the scale that I'm talking about here, like SpaceX, I'm pretty sure the very beginning was they had their budget, they had 3 attempts, 2 of them failed. If the third one failed, they were kaput. So instead, obviously, they swung out versions, and the third, it might have been the second or the third. I don't quote me on that, but man, like you got a working version. So that's the kind of like appetite for risk that successful companies are doing. And like, obviously this is leading space tech, so. And like, for good reason. It's just not like joyrides for celebrities. I didn't like which is like definitely an industry in the future. Like, that'd be so cool, honestly, like if that was. If that was a thing in the future where anybody could, like, space travel was just so abundant that you could just be like, yeah, I wanna hop on a trip to Mars. Let me just pay like a bus ticket, some Star Wars stuff. Yes. Mm-hmm. Not all that, I just... Space tourism, it's called. Crazy. Some new age stuff for sure. No, I'm okay. What are we at? 73 minutes? Okay, then we'll just end probably a little bit early here. So search over here. RBS number 1, RBS number 2. Revieri. I don't know if I'm pronouncing it. Let's just listen to some nice...
Sword 2 video generation is not available in our region.
It is if you're on Artlist.
Huh?
Wow. This might be my favorite. What is this guy's deal? that's a good point right there in that comment. Like, I always see like a bunch of artists doing the live version and they just like spin it up. They're like complete. Like, have you ever heard Travis? Like, he'll just completely rip a new version of his song, or Kendrick, or like any of these guys. Like, it's a good point. Whoever said this right here. What did that say? Crazy. This guy has the same name as Debussy. That's funny. Never heard this, I don't think. Oh, you know what's so funny? I saw I don't really do a lot of study music. I was just doing this to, I'm okay not doing it. But here. What do you guys say? There's a funny old track, lock-in music. I don't know, grind for the grind. I think it's called. Right? And I was like, this looks interesting. This looks promising. Maybe this is it.
You've got a big new website idea and the team loves it. Instead of taking months to build it, why not just use Frame?
I'm like, this is not any type of lock-in music for me. This sounds like I'm literally just like at a house concert. Like, I would not be able to focus. I'm like, this is for different folks, different whatever. I was just like blown away. I'm like, this is not. I prefer Debussy. Let's keep it nice and as simple as possible. As in the background, white noise. Because I would just be straight like not focusing. This would just be me the entire time. Frownflick. Frownflicking and studying. Anyways, I think we lost the plot here, so I'm just gonna go ahead and end stream. Okay, so this means that I'm gonna go build mode for like the next 7 days. I'm gonna be in the super channeled state of mind, just building, getting a working version out there, testing feedback until I post my next video. So it's been fun, dude. This is like quite the, I'm talking like it's the end of something, but like it's just the beginning. I get it, but nice to get my feet wet and try this all out. So I'm glad that I got something to reference back here. So anyways, that's it. I will see you when I have some